Testing? Testing? All right, this is continuing with figure 2.5 on page 60. I'm sorry, on page 50, I believe. On page 50. I made a couple of changes and learned a couple of new items. I was having trouble with this compiling successfully. So I placed the pound sign include standard AFX.H header statement first, immediately following the beginning documentation statements. Can't give you a good reason why. That seems to have helped in the situation. I also made sure that the project properties were set correctly to C++, pre-compiled headers, and make sure you choose that drop-down arrow and select not using pre-compiled headers. Apply and then say OK. I had not done that, so that's a likely major problem. And then we had updated with system pause and return 0. Now I'd like you to use Control F5 to run your program. When we choose the Run Local Windows Debugger, it does execute for us, but it also turns on the debugger, and we don't need to have it turned on all the time. It's a useful tool, but we don't need it always on. So choose Control F5. And we are executing our program now. And it says enter the first integer. Well, of course, that's one of our prompts. Write this quoted material, enter first integer, quote, enter first integer, colon, space, leaves that quoted blank space for us to enter our number. And the first number they suggest was 45. I'm going to enter to do that and enter the second number, and they suggest 72. I'm going to enter that at the keyboard, and my sum is 117, just as we would expect. So our prompts at the keyboard, on our output screen, enter the first integer with a colon, and then that quoted space allows us to have a space after the colon on the output screen. And then I typed in 45, enter this, and that 45 as an integer was successfully assigned to number 1 in addressable memory. And then we sent to the output display, enter second number, colon, space, and that's where you get this space. I typed in 72, hit the enter key, and 72 as an integer was assigned to my number 2 integer named storage location. Now we're ready to do some processing. Sum equals. This is our assignment statement. Just like in algebra, sum equals number 1 plus number 2. We're adding, we use the plus symbol in C++. So sum is overwritten with 117 and stored in addressable memory. And now I'm going to output to the standard console. Sum is space. I have sum is space. And I'm outputting with the lesson. I'm sending it to the output standard console device. Sum's value currently is in current memory 117. I'm done. The output screen is paused, and we have press any key to return. So be sure to read the author's dissection of the statements that follow the listing of the program itself in the chapter. All right, then we are on page 55, looking at our arithmetic, how C++ handles our arithmetic operators syntactically. So our operation of addition, the arithmetic operator is a plus symbol. Algebraic expression is maybe f plus 7. And for C++, we have our variable f plus 7. Subtraction. And arithmetic operator is our hyphen or the minus symbol. Algebraic, P minus C. And our C++ expression would be P minus C as well. Multiplication, arithmetic, we use the asterisk. If I had something like B times M or B with the dot M, in C++ we have to use the star. The star represents multiplication only. Division, our arithmetic operator is the / in C++, x divided by y, or x over y as a fraction, or x divided by y. In C++, we have to use x / y to represent division, and that's the only operator we can use for division. And then your remainder, the arithmetic operator is a percent symbol. It stands for a modular arithmetic. R mod S is the algebraic expression for C++. It's our percent S. And the only one of those that I think you may see new to you would be something like 7% 4. That is modular arithmetic with our mod operator. And integer 4 goes into integer 7. Well, it goes in there once. That'd be 4. Subtract, we get an integer remainder of 3. So our answer is 3. We're looking for the integer remainder. Another example might be 17, modular arithmetic 5. So 5 goes into integer 17 3 times, that'd be 15 minus 2, with a remainder of an integer of 2. So our answer is 2. The integer remainder when I divide 17 by 5 and use your percent symbol as the modular operator. On page 57, be sure to acquaint yourself with the order of precedence, just as it is with your algebraic precedent rules and with your calculator rules. We think sometimes PIMDAS maybe, please excuse my dear Aunt Sally. Be sure to understand the order of precedence with respect to your operators, and there's a couple of examples as well. We introduce our relational operators on page 59. From algebra, relational or equality operator. A relational operator is greater than. C++ relational operator is greater than. Sample of C++. X is greater than y, and what does it mean in C++? X is greater than y. Less than, pretty straight across. Our syntax is x is less than y, and it means x is less than y. Our relational operator in algebra is greater than or equal to, we have the bar underneath. Well, of course, we can't find that type of a symbol on our keyboard. So for C++, we type greater than or equal to. So you type the greater than symbol and immediately follow by the equal sign. So a sample code would be x greater than equal y, and we're asking x is greater than or equal to y. Is that true or false? Syntactically, we can write less than or equal to with the bar underneath the less than symbol, but of course there is no physical key like that on the keyboard. So in C++, our syntax is less than equal sign. So sample code is x less than or equal to y, and it has the meaning x is less than or equal to y. Our equality operators, algebra, we use the equal sign. When we're testing for relational equality, equal, equal. You type the equal key twice. And our sample is x equal y, and we're asking the meaning, the condition, the relationship is x equal to y. Not equal to, well, we can't slash. There's no symbol equal slash on the keyboard. So in C++, we use the exclamation point for not equal and then the equal sign. Our sample code x not equal to y, and we're asking is x not equal to y. Spend some time understanding those relational operators, and they are discussed, and the syntax is dissected in the following pages. So we want to try to get the program on page 60, figure 2.13, to execute as successfully as a project. Note on page 61 that we've been using the declarations using standard, dot, colon, colon, C out, standard, colon, colon, C in. There is a modified way. Many programmers prefer to provide the using directive rather than using the standard colon, colon throughout our code. So we can simplify our code by using the using directive, using namespace, std, semicolon, and that enables your program to use all the names in any standard C++ header. So it simplifies our code, and we may want to try that, or you may want to try it if I don't get a chance. You could replace these statements 6, 7, and 8 with using namespace std, semicolon, not the comments. You'd replace them with the statement, the using directive on page 61. All right, let's see if we can get this program to execute in our C++ compiler environment. So I'm going to save this, close the solution, and exit. Starting a new Visual Basic project. Close my start page. File, new, project. Windows Desktop, Windows Console. This is figure 02.13. I can't use a decimal point, of course, so figure 02-13. Make sure that your location is correct. We are working from the C drive. In your first name, we're still in chapter 2. We're going to select that folder, everything populated correctly, and say OK. It's now creating the project with all the supplemental folders and helper files. Right, we don't need this file to recall, so I'm going to delete that. Remove and delete. And the author is sharing a file with us, so I'm going to go out to Explorer and get that file, which is you mean that one? It was a sample. It's actually should be figure. I'm going to drag that across. And I have actually copied and pasted the shared source code into my source files of my project figure 02/13. And we're comparing integers using our if statement. We're using rational or relational operators to test for a relationship between two numbers, and we're testing for equality. Pound sign include IOStream, and here they're using all of the using. At this point, I'm just going to let that be. I'm going to pound sign include standard AFX.h as that first included file or included statement. I'm going to add my in the main function as the very end, so just before the and brace and end comment, I'm going to add system, pause, semicolon, and spell correctly, and return 0. Remember a project setup, project for this project, C++, pre-compiled headers, click your pull down window. We are not using pre-compiled windows, apply and say OK. With those changes, I'm going to do a file, save all. Now, we are experimenting with our relational operators and our equality operators. So let's see what's happening. In our main function, we have declared number 1 and initialized to 0 as an integer, declared and initialized number 2 as an integer, and assigned it to 0. On startup, we're going to prompt the user, enter 2 integers to compare, colon, and then a space is quoted. We're really trying to maintain easy reading and writing on your output screen. We're going to get from the keyboard whatever the user types, and we're going to hope the user types an integer. We have no error prompting going on here. So we're going to get the integer that the user types at the keyboard, assign it to number 1, and the second input integer from the keyboard will be assigned to number 2. Now we're testing with the if statement. And the if statement tests a condition within parentheses. And we're testing if number 1 equal number 2. Remember, that's our equality test. It's not an assignment statement. Equal is asking, are these two numbers equal? Yes or no? We have our open brace and close brace. If the condition tests true, we'll process this line. Otherwise, we won't. If it's true, we're going to output number 1 to the console. We're going to output quoted material space equal space, and then number 2's value. If we have another statement, test the condition if number 1 is not equal to number 2. If that's true, we'll process the body of the loop, and we're going to output number 1's value not equal to space number 2's value. If number 1 is not equal to number 2, we will print that. Otherwise, nothing happens. We only process the body of the loop, the body of the if statement, if the condition is true. Here we're testing with an if statement if the two numbers, number 1 is less than number 2. If so, we provide output to the screen. This is an if condition. If number 1 is greater than number 2, we're going to output the true portion, or we skip that if it's false. We have another condition. If number 1 is less than or equal to number 2, then we will output a appropriate response. Otherwise, we do nothing. Next, if number 1 is greater than or equal to number 2, if that's true, we output a proper response, and we're done. Now remember, we're going to be using Control F5 rather than calling on the Windows debugger. Yes. And what does it say this time? Okay. Enter 2 integers to compare. Well, your textbook starts on page 61 with entering 3, spacebar, and 7. And of course, the system recognizes that as 2 separate integers. Number 1 is going to be assigned 3 in addressable memory, and number 2, variable name in addressable memory, is going to be assigned 7. Enter. And now it works through the program, and it determines that 3 is not equal to 7. It's a true response, so it outputs the statement in that condition. The next if statement found to be true is 3 is less than 7, so it outputs an appropriate quoted response. And then it also determines that 3 is less than and not equal to 7, and it outputs that appropriate response. Press the key to continue. Let's try again. Control F5 to execute. Doesn't involve the debugger. Let's try 22 and 12. This time, number 1 is greater than number 2, and number 1 is not equal to number 2. So let's see. 22 is not equal to 12 was tested as a true statement. 22 is greater than 12 was tested as a true statement, and we have the appropriate cout message to the screen. And 22 is greater than or equal to 12, the appropriate true body of that condition was printed to the screen. And let's try one more. Control F5 to execute does not turn on the bugger, which sometimes isn't necessary. Enter 2 integers, and this time we're going to have an equality test, 7 and 7. Well, 7 is equal to 7. And we have 7 is equal to 7. 7 is less than or equal to 7. And 7 is greater than or equal to 7. And again, as we start executing, if number 1 equals number 2, then we output 7 space equal space number 2, which is 7. Is 7 not equal to? No. Is 7 less than? No. Is 7 greater than? No. Is 7 less than or equal to 7? Yes. So we're going to output 7 space is less than or equal to space 7, number 1 and number 2. And is 7 greater than or equal to number 2? Yes. So we're going to output 7 space is greater than or equal to space 7. 7 space is greater than or equal to space 7. So again, make sure that you observe the spacing controlling your output screen so that it is reader friendly with quoted spacing as necessary. All right, we did have a problem the first time I tried to compile this, and it didn't like my # include, so I just commented that out. And normally you get those messages at the bottom, and that was the hint, so I really got rid of this. And I see that it's over here and here as a header and as a source file, so let's file save, all. Control F5, do not start the debugger processing. And enter 2 numbers, 4 and 4. 4 is equal to 4, 4 is less than or equal to 4, and 4 is greater than or equal to 4. And I'm satisfied with that output. Now you can go ahead and test this with multiple runs with Control F5. All right, that finishes up chapter 2. There's the wrap-up material to read through, extra studying on your part, of course, and return to D12. I just say always return to D12 Brightspace, your particular unit number lesson plan of study. In this case, it's chapter 2 for your homework, any projects, any tests, due dates, and all their details. All right, thank you very much.